Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the A-level mathematics topic of finding the equation of a circle when we have 3 points. So any 3 points, well not any 3 points, because if they're in a straight line it won't work, but almost all sets of 3 points define a circle. If we've got 3 points it usually defines a circle. If the points are in a line then it won't define a circle because there's no circle that could fit through those. In a sense a circle would have to have an infinite diameter. But usually 3 points do. So let's take 3 random points, A, B and C. A is 2 minus 4, B is minus 3 and 1, C is 5, 5. What is the equation of the circle that passes through them? So what we're going to do first is work out the equations of the straight lines that go through the pairs of points. This is quite a long method, but you can get this as an A-level question. So for instance, if we look at the line going through AB, we take, we've got a video that does this, but we take the change in y and divide by the change in x. So the change in y is 1 minus minus 4, and the change in x is minus 3 minus 2. So that gives us 5 over minus 5, which is minus 1. Then we substitute in one of the points. Let's say we substitute in 2 minus 4, so that tells us that minus 4 equals minus 2 plus c, so c is minus 2, and the line is y equals minus x minus 2. And just very quickly, it's worth checking that a and b both go into that. So if you put in a, it's minus 2 there and minus 4 there, that works. If you put in b, it's minus 3 there and 1 there, that also works. And this is what that line looks like. Minus x minus 2, as we can see it's going through the y-axis at minus 2 and indeed the x-axis at minus 2. Okay, so we work out the next point, the next line. So this is the line AC, and I won't go through all the detail, but it comes out as y equals 3x minus 10, which is like this. So it's got a positive gradient, quite a steep gradient, and then if you kept on projecting it downwards it would hit the y-axis at minus 10. Then the next one, BC, we work it out in the same way, and we get that as y equals x over 2 plus 5 over 2, which you can write as 2y equals x plus 5 if one doesn't want to have kind of quotients in there. 2y equals x plus 5 looks kind of nice. And that's that last line there, so we can see it's got a gradient of 1/2, and it's hitting the y-axis at 5 over 2, which is 2.5. All looks right. Now, the next thing we have to do to find the equation of the circle is to find the centre of the circle. And what we remember is, from our GCSE, what we remember is, if you have a chord of the circle, so all of these things like BC, AC and AB will be chords. If you have a chord and you have a line from the centre of the circle which bisects the chord, then it meets it at 90 degrees. So what we're going to do is find all the bisecting points on these lines. So here, let's do AB first. So AB, we do the midpoint of AB, which is just the average of the points A and B, which is minus 1/2 and minus 1.5. So it's just literally minus 3 plus 2 divided by 1/2 is minus 1/2, and then it's 1 minus 4 divided by 2 is minus 1.5. And also, to get the perpendicular, we need the line that is perpendicular to minus x minus 2. So what we do is we take the reciprocal, and then the reciprocal of the gradient, and then we take the negative of that. So it's the negative reciprocal of the gradient. So y equals minus x minus 2. So the perpendicular is y equals x plus c, because the reciprocal of 1 is 1 and the negative of minus 1 is 1. So y equals x plus c, and then we're going to substitute in minus 1/2 minus 1.5, and we get c equals minus 1. So the line equals y equals x minus 1. And there it is. That is the line. We can see it's cutting the y-axis at minus 1. And we can see it's y equals x. By the way, these should be perpendiculars. Now, they don't quite look perpendicular, and I think the reason for that is because the x scale is more stretched than the y scale. So this isn't drawn to scale, so it's kind of indicative, but in our heads, these are perpendiculars here. This is because basically this has gradient 1 and this has gradient -1, so they ought to be, they're perpendicular even if they don't look like it because of the way the graph is drawn. Okay, now for AC, we started with y equals 3x minus 10, and so the perpendicular is y equals, we take the negative reciprocal, so it's minus a third is the gradient of the perpendicular. So we've got y equals minus x over 3 plus c. The midpoint of AC is 7 over 2, 1 over 2, so we substitute that in, and it's a little bit of fractions here. We get a half equals minus 7 over 6 plus c. So c is 10 over 6, 5 over 3. So we have y equals minus x over 3 plus 5 over 3. And the line that we're drawing, that line is this one here. And all of a sudden we can see they're crossing at 2, 1, and this is going to be significant, as we will see going down the line. Okay, BC, we already have y equals x over 2 plus 5 over 2, and so the gradient is the negative reciprocal of a half, so it's minus 2. So y equals minus 2x plus c. The midpoint is 1, 3. The midpoint of BC is 1, 3. So the average of 5 and minus 3 is 1. The average of 5 and 1 is 3. So we substitute that in, and we get 3 equals minus 2 plus c. C is 5. So the equation is y equals minus 2x plus 5 of the perpendicular. That's the equation of the perpendicular. And so that's coming off of BC. So it's this, isn't it? Y equals minus 2x. And then if we projected it, it would go through 5, which is good to know. And again, we see it going through the point 2, 1, which is interesting. So we got to see where these lines intersect, and they ought to intersect at the center of the circle, because all of these lines are going to be lines from the center to the chord, and they're perpendicular lines. So we got y equals x minus 1 as one of the equations. We got y equals minus x over 3 plus 5 over 3, or 3y equals minus x plus 5. Actually, that's a nicer way to use it than y equals minus 2x plus 5. So if we add the first two, y equals x minus 1 and 3y equals minus x plus 5, if we add those, you get 4y equals 4, hence y equals 1. And then if you put that back in, say you put y equals 1 here, x needs to be 2. So the answer is x is 2, y is 1, which was kind of what we trailed here visually. Also, we pop this in the third equation just to make sure it satisfies this too. This is where all three equations meet. So if x is 2, y is indeed 1. So this is the center, 2, 1. And then we can work out the radius, because the radius is just the distance from 2, 1 to, say, this one, which is easy because they've got the same x coordinates, so the distance is just 5. And the distance here, they've got the same y coordinates, so the distance is just 5. And then the last one, the distance to c, I mean, it's going to be the same, but just to check, you do it by Pythagoras' theorem. So you've got sort of a right angle triangle. You've got one side is 3, the other side is 4, and the hypotenuse is the difference. So it's 3 squared plus 4 squared is 25. Take the square root is 5. It's a 3, 4, 5 triangle, basically. So this means the equation of the circle is x minus 2 squared plus y minus 1 squared equals 25. And just to double, triple check, because it's always nice to do these things, let's pop these numbers in and make sure they satisfy this circle, because the whole point is this is the circle on which all these 3 points lie. So you put in this one 2 minus 4, and this goes to 0, and this goes to 5 squared, which is 25. Put in this one minus 3, 1. This goes to minus 5 squared, which is 25, and this goes to 0. Put in this one 5, 5. This goes to 3 squared, which is 9. This goes to 4 squared, which is 16. 9 plus 16 is 25. It all works. Hope you liked this video. I liked making it a lot. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.